Hi, everybody. Welcome back. Today, we're going to start learning our third and final way of solving systems of equations. Today is probably one of my most favorite ways. It's by elimination. How many times can you tell somebody that you get to eliminate something? Pretty exciting. So let's start by looking at the box. Our essential understanding, your whole goal in this whole process is to eliminate a variable. We know how to solve an equation with one variable in it, but now we have equations that have two variables, so we have to completely eliminate one, so that way we can do all of the solving stuff that we need to do. So when you're using this elimination method, the first thing that you want to do is check and see if there are two variables that are exact opposites. So for example, you might have a 3x in one equation and then a negative 3x in the other equation. If you do not have two variables that are exact opposites, then you want to look for two variables that are the exact same. So you might see something like a 2y in the first equation and then a 2y again in the second equation. The signs are the exact same. You could also see something like a negative 4x and a negative 4x. So it could be two positives or two negatives. Either way, your next step then would be to multiply one equation by -1. Only one equation, because if you multiply them both by a -1, you're going to change both signs so they're still the same. Our final thing that we look for, if you don't have two terms that are exact opposites or two terms that are the exact same, then we're going to have to multiply both variables to get something to cancel out. But we're not going to do that today. We're going to stick with just things that are exact opposites or ones that are the exact same. After we get done taking care of steps 1 and 2, what we need to do is add our equations. And when we do that, we eliminate a variable. Finally, we're going to substitute the variable into an original equation. So that way you can find the value of your other variable, and then we write it as a point x comma y. So I realize those are a lot of steps, and sometimes it's hard to understand the steps when we're just discussing them. So let's get started by looking at an example. Number 1 is saying solve that system of equations by using the elimination method. So if I look at my equation here, we have two variables that are two terms that are the exact same. So two terms that are exact same. I have a negative 5x and a 5x. Sorry about that. We have two terms that are exact opposites. So let me fix that really fast. Okay, so we have two terms that are exact opposites. We have a negative 5x and a positive 5x. Because we have two that are exact opposites, we can, what we say, stack them and add them. So now when I add up a negative 5x and a 5x, that gives me 0, right? So that means that that is eliminated. And so now I go ahead and add the other ones. What is a negative 3y plus 2y? Good, a negative 1y. And finally, what is negative 7 plus 3? Great, negative 4. Now, y is not by itself because I have a negative sign in front of it, so I do need to go back and divide both sides by that negative 1. So when I do that, I get y is equal to a positive 4. So that's great. I found out what y is, but I still need to go back and figure out the value for x. It doesn't matter which equation you choose. I typically choose an equation that has small numbers or that are positive to go back and substitute this number in for y to figure out what x is. So for me, I'm going to look at the second equation because all those numbers are positive. So I'm going to take the equation 5x plus 2y is equal to 3. And I'm going to rewrite it substituting that 4 in for y. So it's 5x plus 2 times 4, because that's what y is equal to 3. So what is 2 times 4? Great job, it's 8. So I have 5x plus 8 is equal to 3. So from there, I need to subtract 8 to both sides. Good. So I'm going to rewrite it up here because I'm kind of out of room. I have 5x is equal to, what's 3 minus 8? Carefully watch your sign. Great job. It's a -5. Final step, you got this. Divide them both by 5, and we find out that x is equal to a -1. So if I were to graph the systems of equations, they would intersect at the point -1, 4. Okay, let's look at another one. Number 2. Again, we're asking ourselves, do we have two terms that are exact opposites? So if I look at my x's, they're not exact opposites. But my y's, I have two terms that are exact opposites. And which ones are they? Good. You have a -4y and a 4y. They are exact opposites. So because I have exact opposites, I can stack them and add them. So when I do that, what is 10x's plus -7x's? Good job. It's 3x's. And -4y plus 4y is 0, so the y's get eliminated. And that is equal to, what is -20 plus 14? Watch your sign. Great job, -6. So from there, what do I need to do? Right, we're going to divide both sides by 3, so x is equal to a -2. Now that we have the value for x, we get to choose our adventure to figure out what the value of y is. So when I look at those equations, I have 10x minus 4y equals -20, or -7x plus 4y equals 14. I like the bottom equation better, but it doesn't matter which equation you use. So instead of saying -7x plus 4y equals 14, I'm going to rewrite it, and I'm going to say -7 times that value of x, which is -2, plus 4y is equal to 14. So what is 7 times -2? Great job. It's 14 plus 4y is equal to 14. I'm still trying to get y by itself. Good. I need to minus 14 to both sides. And again, I'm running out of room, so I'm going to bring it up here. So 4y is equal to, what is 14? Take away 14? 0. My final step is to divide both sides by 4, and I find out that y is equal to a 0. So when I write this intersection point, it's going to cross at the point -2, 0, if I were to graph those two lines. Okay, so in both of these situations, we had two variables that were the exact opposites. Now let's look at our next set of problems. If we look at number 3, you're going to see that I have two variables that are the exact same. So I have two sets of it in this case. I have exact same. I have a 7x and I have a 7x in each equation. So if we go back to those steps, we said that if we have exact sames, we need to multiply an equation by -1. So I'm going to multiply the top equation by -1. So when I do that, a -1 times 7x is a -7x. A -1 times a -4y is a positive 4y. Equals, and I have to do the other side of the equation even. 18 times a -1 is a -18. Now that I've written that down, I can stack them and add them. So this one's a special case. It's actually very, very special. When I do 7x's plus -7x's, that gives me 0. So my x's get eliminated. But when I do -4y plus 4y, my y's also get eliminated. So I've got nothing left on that side of the equation. Knowing that I have nothing left on that side of the equal sign, what number represents nothing? Good, 0 represents nothing. On the right-hand side, what is -10 minus 18, or -10 plus a -18? -28. So is 0 the same as -28? No, so it's no solution. Good. Looking at number 4, okay, so number 4, again, I have exact same. So I've got the exact same. So I need to multiply one equation by -1. I have a -8y in the top equation, and I have a -8y in the bottom equation. So I'm going to multiply that top equation by -1. When I do that, a -1 times -2 is a positive 2x. A -1 times a -8 is a positive 8y. And that's equal to a -1 times 0 is still 0. Now I can stack them and add them. What is -8x's plus 2x's? Great job, -6x. A -8y plus 8y gives me 0, so they cancel out. They get eliminated. And finally, what is 0 plus 0? It's still 0. My final step here is to divide both sides by -6. So x is equal to 0. Be careful, it's not no solution because I still have an x in there. So that's why the answer is 0. Now that I have that part, I need to go back to an original equation to substitute it back in. In this situation, it doesn't really matter which one, so I'm going to use my top original equation. So instead of saying -2x minus 8y is equal to 0, I'm going to say -2 times what x is, which is 0, minus 8y equals 0. Well, -2 times 0 is 0. So I just have -8y is equal to 0. My final step, you got it. Divide them both by -8, and I find out that y is also equal to 0. So if I were to graph the systems of equations, they would cross right smack dab at the center of the graph, 0, 0. They cross at the origin. Good job. So we're going to ignore the directions for a minute. We're going to have those directions apply to number 6. I want to take a look at number 5. If we look at number 5, you see that you have exact same variables. So the first thing I see is an 8x in the top equation and an 8x in the bottom equation. So because I have exact same, I can multiply the top equation by a -1. So what is -1 times 8x? Good. -8x. What is -1 times -3y? Great job watching your signs. A positive 3y. And finally, what is -1 times 10? Awesome. A -10. So now that I have exact opposites, I can stack them and add them. So I have a positive 8 and a -8, so the x's get eliminated. I have a -3y and a positive 3y, so the y's also get eliminated. So everything is eliminated on that side of the equation. So what number represents nothing? 0. Good. Is equal to, well, what's 10 plus a -10? That's also equal to 0. Because I have the exact same on both sides, this is what we call infinite solutions. Okay, so finally, number 6, I'm going to start us off on the problem, and I'm actually going to jump to the answer. So if we look at number 6, I see again that I have exact same terms. For example, in my first equation, I have 6x. In my second equation, I have 6x. So because I have that, I need to multiply both sides by a -1. When I do that, I end up with a -6x. See, a -1 times 9 is a -9y, and a -1 times a -6 is a positive 6. Now I can stack them and add them. What I want you guys to do right now is hit pause and figure out what your solution is. So hit pause now and work out the problem. Okay, so now that you've had a chance to work out the problem, did you get the point 8, -6? If you did, amazing. If not, go back and rework the problem or check the notes that are posted to see where you made your mistake. However, looking at this, it says in the directions that I circled that you want to evaluate x plus y. So you go through, you do all of that work. However, our final answer is going to be x plus y. So if we look here, 8 is in the x position, y is in or -6 is in the y position. So our final step to get the answer I'm actually looking for is to do 8 plus my y, which is -6. What is 8 plus -6? 2. And 2 is our answer. And I'm going to put a heart around that because we love the fact that you guys have completed today's notes. So if you have any questions at all, feel free to see your teacher. Otherwise, I think now would be a great time for you to go ahead and get started on your classwork. Thanks and have a good day. Bye.